Hey, y'all. Welcome back to What's Up, powering smarter homes, stronger businesses. As we gear up for Mardi Gras here in Louisiana, I'm back with my main man, Mr. Darren Gomez. Over the last few episodes, we've been living in the Solar 101 world, right? How solar works, what it costs, and how to know if it's right for your home. But today we're hitting the step that most people skip. And it's the step that makes solar actually perform the way that it should.
Yeah, before you ever even put a panel on your roof, typically you really should look at how efficient or inefficient your house is so that the power that you're putting on your roof is actually going to cover your usage, right? So you want to maximize what you're offsetting essentially in terms of what you're paying for your utility bill.
Absolutely. Insulation, air sealing are the unsung heroes of energy savings. And so today we're going to be talking spray foam, traditional insulation, open cell versus closed cell. We'll include some real customer stories and why the smartest move is almost always Darren and I's favorite topic: reduce before you produce. So, y'all, without further ado, we're just going to jump right in. And this is going to be a pretty Darren heavy podcast. So, I'll be shooting you some questions. We'll listen to some stories. But Darren, let's talk why insulation matters.
Yeah, why insulation matters. It's a great question, and most people don't even think about it because it's out of sight, out of mind. But insulation matters because it is the one thing that stops your outside elements from affecting your indoor comfort. Let me say that one more time. Outside elements affecting your indoor comfort. It's not the only thing, but it's the main thing that basically helps us feel comfortable in the home, both in the wintertime and the summertime.
And so, Darren, are we worried about air getting in or air getting out, or should we be worried about both?
Yeah. So traditionally, when you talk to an insulator, they're just talking about how much insulation they want to add to your house. Over the years, as we get smarter, if you will, or really as government entities and building codes start to dictate, we start looking at other things. So air infiltration is a huge part of properly insulating your home, and it's something that's rarely looked at, and sometimes can be very difficult to address specifically. So to answer your question, what we want to do is eliminate as many air exchanges as we can between the inside and the outside. So the money we spend to cool the house in the summer, we want to keep in the house longer. And the money we spend to heat a home, we want to keep that heat in the house longer, depending on the time of the year and or your geographic location. So keep the air in.
So we're talking about your house losing energy through air leakage, like Darren was just talking about, conduction, and even radiation, right? Because like Darren was just saying, most often comfort issues come from poor envelope, not your lack of power, right? Not your lack of solar.
Right.
So,
Yeah. So, specific to that, solar is just going to help offset your consumption, right? It's not going to reduce your consumption, which is what insulation does.
right. And we all know with a well sealed home, Darren and I've seen this specifically with our old company where the better you insulate a property, you can actually tend to a smaller solar array, right? Smaller solar system and even a faster ROI.
Yeah. So I believe it's the Department of Energy says that insulation has the fastest ROI of any home improvement upgrade that you can do, whether it's windows, doors, solar, whatever it is. And so when you package that with a good solar system, now you have a competitive advantage against other solar contractors in that you can provide them with a smaller system to meet their consumption habits, right? So if you have a house that is 15 years old and it has insulation that is 15 years old, we can upgrade that insulation and maybe reduce their utility bill by 10%, at least their heating and cooling bill by 10%. And then we can size the system that better reflects their usage versus, hey, I think you're going to use X amount and build this oversized system.
Well, because this is a good way to put it, right? When you putting solar on a poorly insulated house is like filling a leaky bucket with a bigger hose.
Exactly. That's exactly right. It's a good analogy. One of the things that people tend to overlook when it comes to insulation is how much it reduces your bill, but not only that, how much it improves the comfort of your home. And so, good insulation could also change your habits on how you heat or cool your home in terms of thermostat, of where you set your thermostat.
And that makes a big difference. Like down here for us, especially in the summer, we're getting to 100, 105 degrees on the regular. And your house, I don't mind if I don't run my AC, I can stay comfortable around 76, 78 degrees just with my insulation, but it definitely makes a difference.
Yeah, so humidity, moisture plays a direct impact on our comfort level.
Mhm.
And so we talked about that air sealing. If you can stop that outside air, which has all these elements that we can't control, like relative humidity and moisture, from coming in the home, then your air conditioning system basically will maintain relative humidity somewhere between 50 and 55%, which is, as human beings, is where we're the most comfortable. And so with lower humidity, you can actually set your temperature higher and feel the same comfort as higher humidity with a lower set temperature on your thermostat. And we know that if you're lowering your thermostat, that dude is running more often than if you're not. So that's
Right.
kind of where that's those savings start to really pile up.
Yeah. So, I mean, obviously, insulation matters to me. I'm thankful I have it. So, let's kind of jump in, D. Let's talk some specifics, right? What's the difference in spray foam and traditional insulation?
Yeah, so it's a great question. It can be a complicated question, kind of, at least in a customer's mind, but it's pretty simple. There are some very big differences between spray foam and traditional insulation in how this house works as a system. I'll
Mhm.
explain that in just a second. So, all building material has an R value. What is an R value? Simply put, R value, and we said this in one of our previous podcasts, if not a couple of them, is the resistance to heat. The higher the number, the more it resists the heat. Now, so typically, in the southern climates, in attics, we're at an R38. In the northern climates, we may be as high as an R60 in the attic to stop that because it's the biggest surface area that affects our comfort, right? So those numbers are dictated by the government, and we insulate to those standards. Now that's traditional. With spray foam, it indeed still has an R value that is very similar to the R value of traditional insulation, like the Pink Panther bats or the blown-in fiberglass, or even foam board for that matter.
Mhm.
Um, but where spray foam far exceeds your ROI and your comfort is that it seals in the home. It essentially creates an envelope wherever you apply it to. So on a new construction, if you're doing walls and roof, it makes that home air sealed, an envelope that does not allow air penetration, both moving in and moving out. And now your air conditioner is in a cool environment, and now you're starting to see the effects of lower humidity. And so all these things start to play a factor in. And so you start to see that with a spray foam house, you've basically addressed all the issues that traditional insulation don't typically do. And most of that is air movement.
Right.
Um, that's one piece of it.
So, like
Um,
with traditional insulation, I get mostly we're talking about the batting, right? I mean, that's it's lower cost, but that seems like you have to put it in pretty perfect, and that doesn't create the envelope we were just talking about, right?
Yeah, yeah. So with traditional insulation, there's a lot of pieces that will reduce that R value, right? Um, First off, before you even install the fiberglass batch of the blown-in fiberglass, you have to seal every single penetration up to the exterior or between the living space and outside. Remember, on a traditionally ventilated attic, the attic is considered outside. So every
Mhm.
ceiling penetration you have, whether it's I'm going to say this, it's funny because I think it's funny, whether it's a fart fan, can light, electrical, I know it's so funny, electrical box, um, whatever that penetrate speakers,
Mhm.
whatever the penetration in that ceiling, which is part of your envelope, is, you have to seal up because when your air conditioner kicks on, it's going to draw that outside air in naturally. It's very hard to get a neutral um, air movement with your air conditioning system. Typically, you're drawing in and having a negative air effect as opposed to slightly positive, which is supposed to be. There are houses that are, and there are good HVAC companies that do it, but it typically costs more, and the person has to have a lot more knowledge. So, first, that's the first thing you have to do before you even apply the traditional insulation like a fiberglass bat. Secondly, you have to put that fiberglass bat in that space perfectly, meaning you're not compressing it, crunching it, bending it. It has to be precisely cut between the studs of whatever you're applying it to. If it's a fiberglass bat, and any compression reduces R value. Any air movement reduces R value. And so it's you may put in what's code, which is is R13 in the walls in the southern climates and R38 in the ceilings. But if you have any of those other factors I talked about, that R value starts to dip pretty quickly.
Drops down.
So that's why we like blown-in fiberglass traditionally, or some type of blown-in insulation in the ceilings, because it tends to fill some of those nooks and crannies a little better than if you didn't fill them up or seal them up with spray foam or something like that, or a can foam, whatever the case may be.
Now, so as we move into spray foam, that's where we get into the discussion of open cell versus closed cell, right?
Yeah. So open cell versus closed cell, which is the easiest way to think about it is open cell is used for interior applications where moisture is controlled. So we're talking about a home, essentially, or an office building, something where you're going to be controlling your humidity and your moisture, essentially. It can be applied in commercial settings, but it has to be the right settings. I always say, always defer back to your insulator. They should know how to apply it and when to apply it.
Right.
Open cell has the lower R value that is more akin to traditional. So right around that 3.5 to 3.8 R value per inch. Where closed cell is hard and rigid and has somewhere between 6.8 and 7.2 R value per inch. Now the difference between the two in terms of insulating is not super different. And I say that with a couple caveats. In the southern climates, whether you use 6 inches of open cell in the attic or you use 2 inches of closed cell in the attic, you're not going to see a drastic difference in utility savings and comfort.
All right.
When we start to get into the colder climates, that's when we start having conversations about, do we have enough open cell to prevent ice damming or something like that? And do we have enough closed cell to do exactly the same? And how is moisture going to affect that insulation? Because like I just said, air movement, compression, and moisture reduces R value in traditional insulation typically.
Because that closed cell, that offers a vapor barrier too, essentially, right?
That's right. So open cell does not provide a vapor barrier or a vapor retarder. What it does provide is an air barrier. So it reduces the amount of air movement. Closed cell provides a better air barrier and a vapor retarder and insulation all in one. So typically we see closed cell applications in metal buildings, underneath raised homes, in walk-in coolers, wine rooms, anything that has a lot of moisture that we don't want to affect the insulation.
And is it true that closed cell will offer some structural stability too?
Yes. So closed cell is what is considered a structural foam. Wow. And so it does add structural rigidity and tensile strength to what you apply it to. So in Florida, they use spray foam to glue in the rafters to the decking. So if they don't use spray foam in the house, in the attic, to spray foam the whole attic and make it one unified continuous insulation barrier, they would literally take spray foam and hit the edges of the joists to the decking, and they glue everything together, and that gives them the wind resistance they need. That's how good closed cell is in terms of gluing things down and making it strong. Fortified roofs sometimes use a spray foam as a secondary vapor barrier. You can get a reduction in your insurance costs if you do that. There's a lot of things that closed cell do that open cell doesn't. But from a pure energy efficiency comfort standpoint, They're not going to be a lot of difference between open cell and closed cell other than price.
All right. So what about like when should we use open and closed cell? I mean, we talked about it a little bit, but when should we really use open cell spray foam?
Yeah, so open cell spray foam, any residential or small commercial building like apartments, open cell is more than sufficient to address your comfort and your utility bill. Closed cell is really more for metal buildings, underneath homes, exterior applications where there's not a means of controlling humidity. So there's not a mechanical means of comfort, if you will. So AC systems is what I'm talking about specifically.
Yeah. Okay.
And you're worried about moisture.
And then so as we move along through this discussion about the vapor barrier, the air barrier, let's talk a little bit about like where our homes lose the most energy.
Yeah. All right. So we talked about air movement. We talked about how it affects our comfort, how it affects the performance of insulation. The first thing that we typically do on a home when we're evaluating energy efficiency is what's called a blower door test. A blower door test is simply a piece of equipment that will either pressurize or depressurize a home and then measure the amount of air leakage. It's also called an air leakage test. Once we determine that, or once we set that up, then we can kind of determine where air is leaking from the greatest, to the point where we can actually add up all of the leakage and tell you how big an opening you would have to the outside, as a matter of fact. So you can even do that way. You can take your readings from your air leakage test and go, okay, that you have a 5x5 square inch hole literally in your house right now that you can't even close up ever. So typical culprits of air movement, once you put the blower door on, you can literally walk around the house and start feeling around windows. So that's one place, not typically where you see issues unless they're older single pane, maybe sash windows. Most of the newer windows that go in are usually pretty good, unless they
you feel the air movement, right?
You can literally feel the air blowing on your hand. So you can use a smoke pin, you can use a thermal imaging camera, you can use all kinds of different things to see that air movement. So windows and doors, are they sealed properly? That's what you're checking. Electrical outlets, which is not necessarily outlet leaking as much as the wires that are running through your top plates into your attic space, or if the power is coming from the outside into your wall. And so air is literally being drawn straight through that hole that electrician drilled to run your wires into your wall. So around plates. One place I see it all the time is door jams, interior door jams. See that quite a bit where the striker plate goes. Sometimes that hole is not sealed; it's open to the framing, and then you can put your hand there and it's blowing through just like crazy. So I see that quite a bit. So top plates, bottom plates, where there's multiple jack studding. So maybe there's 3 studs in a place holding up a window or holding up some kind of opening, a beam. We'll see air movement being drawn through those studs. On an existing home, not a whole lot you could do there. In a new construction home, you make sure that's sealed up prior to putting up the drywall. Right. So air movement is probably the single biggest killer of comfort and the single biggest culprit of higher utility bills in conjunction with insulation.
Good. I mean, as a homeowner, what you're going to see typically, right, is you're going to see difference in temperatures between the levels of your home, right? You got a hot upstairs, or if you got super cold floors, high humidity. Darren talked about, optimal humidity is right around that 50-55% range. So you start to get up in the 65-70% range, you got a problem. And then for us in the South, especially when your AC is running just nonstop, right? That's when you probably got something going on in your house. Like I know right now, Darren just mentioned doorways. My German Shepherd has decided to scratch his way through the seal on my outside door to my backyard. So I've got to replace that. I can literally see the daylight coming through the doorway. So I know I've got a leakage there. But those are all kind of definite symptoms when you absolutely need to reach out to your local insulator.
Yeah, and most insulators, at least the good ones, will have somebody who's certified to do a blower door test. Typically, you get certified through the Building Performance Institute (BPI). They have legitimate certifications where people have to understand building science, they have to understand the operation of the equipment, and then they have to also understand how do you fix that problem. So BPI is a good indicator that someone is taking their profession seriously and kind of knows what they're talking about. And there's multitude of certifications that you can get. So yeah, I mean, doorway kerf, the kerf molding is what you're talking about. Kerf door molding. There's metal as well that you can use on doors to create that seal. There's a lot of different products. There's great products. There's foam gaskets you can put behind your electrical boxes that stops air movement. On can lights, the very old can lights, they were literally designed to be open to the attic so that the heat could dissipate into the attic. So those are the worst. You can put can light covers over those and get them sealed up really well that are UL certified so they don't burn your house down. Or they even make now LED inserts with a foam gasket that you can retrofit into those cans that will seal them up better from the front side with that foam gasket. So there's a lot of things that are happening that people can utilize to reduce that amount of air movement between the home and the living space. So that's pretty cool.
Well, and so as we talk sort of insulation, we can look to it like real case studies of homes that we've applied with solar, and you've seen where insulation first reduced system size, where we thought, initially we'd have to put in an 18 kW system. After insulation came in, we were able to reduce it down to an 11 kW system, which ultimately saves the homeowner $12,000 to $15,000, right? So it all comes back to reduce before you produce, right? Because again, the goal is to eliminate as much overuse of your electrical system as possible.
Yeah. I mean, that's exactly right. I mean, so a couple of real cases, but before I get there, Energy Star says that 90% of homes are under insulated. Energy Star, the EPA, pretty much all organizations in that energy efficiency space agree on that. And people are like, there's no way, but there is a way, because if your home is 10 years old, you have 10 years worth of insulation and gravity compressing that insulation, but you have also 10 years of a gap between the code that was being applied then and the code that's being applied now. Right. And as we know in the solar business, utility rates don't go down, they continue to go up, which is what dictates some of these R value requirements. So if 90% of the homes are under insulated in some shape, form, or fashion, that means that yes, you, the typical homeowner, need to look at your insulation and you need to get it upgraded. Simply put. And there's no better way to do that than if you're bundling it with a solar project, because now you can take a loan that may, that may be 10 or 15 years versus a credit card or a one-time payment of X amount of dollars.
Right.
And so it's a great way to do it. Reduce before you produce. If you have an energy efficiency program where you're changing out LED light bulbs, smart thermostats, attic hatch covers, all the things we talked about in the first couple of episodes from an energy efficiency standpoint, and then you include insulation, now you're seeing the savings of 10, 20, 25% on your utility bill. And that's real dollars and real comfort. And so, that's very important to understand, is that your house is likely under insulated. Let's address that first, or in conjunction with a good solar system that's sized properly.
Right. Well, because all of my friends and family that have solar, they know that solar is not going to fix your electrical bill problem, right? But once you get your solar system installed and it's up and running, fixing that duct leakage is going to unlock more of your solar system savings, right? Yeah. So it's all about reducing how much is coming out. Again, so that your solar can produce whatever you need to utilize inside the home.
Yeah, that's exactly right. And those 20 to 25% was really traditional upgrades. It has almost nothing to do with spray foam. So
Yeah.
let's kind of get into spray foam a little bit and the differences between the two. I know we talked about it generally. Let's be a little more specific.
Yeah.
So where is your air conditioning system typically in a home, at least in the South? Where is your AC system?
Right outside in the hot air.
So your compressor is out on the outside, and your air handler, which is distributing the air through your ducts, is typically
in the attic where it's hot as hell.
Yeah, it's in a hot attic.
Yeah.
In some of our northern climates, we have furnace systems that are in the basement that's directly connected to your house as well. And so now, your ducts are running in a cool environment as opposed to a warm environment. But essentially what spray foam will do is it'll take your mechanicals and put them in a conditioned space. Specifically for air conditioning systems, what does that mean? Doesn't have to work as hard to get the home cool. It doesn't have to work as often because you're going to hit your set temperature faster. Not fast enough to short cycle where we have high humidity, but faster to the point where where the unit can dehumidify properly and get you to your set point and not have to run as often, because now that cool air sits in the home longer because we foamed your roof line, which is where most of your air escapes. Now it's sitting in there longer, and you're controlling the humidity and temperature in a way that reduces the amount of power necessary to do that on a regular basis. In other words, your AC doesn't kick on near as often to get you to where you're comfortable in your own home. Right. With the basement, same thing. We insulate the basements, or we insulate the floors of the home to keep that air in. Same thought process. You get longevity on your mechanicals because they're not working in the super hot or super cold environment. Electricity is not like that. Wires and motherboards, because everything's computer now, does not like that fluctuation in temperature and moisture. And so you're really just providing longevity to your mechanicals, but you're keeping the air that you're paying for in the home longer. That's the real value in spray foam versus traditional. You don't have to find every nook and cranny when you're doing spray foam because you're stopping it at the exterior of the home. You're stopping it at the envelope. So who cares if the interior walls have a penetration or the can lights have a penetration, because we want the attic temperature to be as close to the living temperature as possible. And typically that's what happens. The differentiation between temperature of a spray foam attic versus living space is 10 or 15 degrees.
Oh yeah.
Not much. So that's where the real value of spray foam is.
So spray foam creates that whole envelope, right? Whereas like at my house, I've got blown in fiberglass in the attic and I've got traditional insulation in the walls. So it's almost like two separate envelopes, right? I've got my living space and then the attic space.
Yeah, your attic space might as well be outside. I mean,
it is hot as hell all the time.
Yeah, it's very hot.
Or cold, right? But it is essentially outside.
Yeah. There is another way, though, to get your savings and comfort close to spray foam. And I say that tongue in cheek. It maybe not be close, but it's still a way to do it. And that is having proper attic ventilation. We talked about this a little bit. Mm-hmm. If you have good attic ventilation in the summertime, it allows that outside air to ventilate the hot air up and out of the attic space. So the hot air and the humid air, frankly, doesn't sit on the ceiling, and your insulation doesn't have to work as hard to stop the heat from coming in. Ventilation is equally as important as insulation with traditional insulation.
Yeah.
Ventilation increases the life of your roof shingles, right? Because it doesn't create those hot pockets. It doesn't overheat the shingle. Ventilation removes humidity in the wintertime. People don't think about that. Why do we have ventilation in the wintertime? Well, it's removing that humidity. There's more moisture in 1 pound of air in the wintertime than in the summertime because it's spread out, right? And so it feels higher humidity in that 1, cubic foot of air in the wintertime. It may not feel that way, but it is.
Right.
So you want that. You don't want those fluctuations in moisture in your attic, especially in the colder environments, which is where you get ice damming, where ice builds up on your valleys because you're getting all this hot air from inside leaking through your ceiling and through your walls up, and it's condensing on the surface of your roof, and it's literally raining or snowing or freezing on the top side in your house and on your house. And that's a real issue in the winter climates where you have bad air leakage and or poor insulation or and ventilation.
Those ice dams, is that a sign of poor insulation? Is that something you should get checked out?
Yeah, typically if you're seeing ice damming or you're seeing microbial mold growth in your attic decking, it's because you're having a moisture buildup, and that's typically because of that air movement between your living space and your attic space, and not enough air movement from your attic space to the outside. Now, with our recent winter storms, there was a lot of ice damming and valleys and stuff, just because that's where it's going to aggregate anyway,
right.
And that doesn't necessarily have anything to do with that. But typically, you'll see it on the where your roof line meets your soffits, your house. That's you'll see ice damming and you'll see moisture on decking there. That's an indicator of air leakage and poor insulation, typically.
Yeah.
On the lower parts of your. We were doing one insulation job in St. Louis, I believe it was, and I literally got a picture from the installer, and the entire roof deck was iced over. And so, as a matter of fact, it was installed prior, and they were finalizing the electrical. Everywhere there was a panel, there was no ice, and everywhere there wasn't a panel, there was ice. So it was very odd, but it literally was snowing in their attic space. We've seen homeowners. I've told this story before. I had an elderly customer. We insulated and did energy efficiency on her house. She called 9 o'clock at night. My air conditioner is not working, and we sent a technician out, and her air conditioner was working fine. It just cycled off, and she wasn't used to it cycling off in the evening. She used to it running till 9, 10, 11, 12 o'clock at night. Those are real stories. We've had customers who've had utility bills cut in half by proper insulation and ventilation. Those are on the extreme side, but I would say with spray foam, generally you're going to see around 30%. With traditional insulation, somewhere between 10 and 15%. Those are probably pretty realistic, based depending upon where they were originally.
All right. Because I know for me, speaking about my attic, I think now after living here about 5 years, my house is really well insulated, but my AC is starting to work overtime. So I think it's time to add some more ventilation into the attic, maybe get that hot air out of there in the summer as best as I can. Add some turbines or something.
Yeah, I mean, ventilation just generally is a great way to go. You know, you were talking about your AC running and running. The other benefit of spray foam is when your AC is put into your envelope, right? Into the ice chest, if you will.
Mm-hmm.
Who cares if the ducts leak a little bit into that attic space, because it's just going to cool the attic space off.
Right.
But if you have a traditionally ventilated attic and your air conditioning ducts are leaking cool air or hot air, depending on the time of the year, that cool air and hot air is not getting into your living space and is being pushed to the outside. You're literally air conditioning and heating the outside. And so there's efficiency that you can get there by sealing up your duct system if you're going to keep it ventilated, or spray foaming your roof deck and doing a closed system in your attic where you don't lose that money anymore into the outside.
Wow.
Pretty good.
And then so we've talked a little bit about real case sizes with solar, but coming from a solar guy, I mean, that lower kilowatt hour usage, it really allows me to build you a smaller system, right? Smaller systems, you get better financing, hell, even an improved load profile for your home, right? Battery readiness, all these things are kind of encompassed into how well is my home keeping all of the power that I'm producing within itself, right? Yeah. And this is kind of what we're talking about now, but is there anything we're forgetting in terms of like the envelope itself, D?
I mean, your envelope consists of the exterior parts of your home. So whatever part is adjacent to your outside. Remember, your attic and a traditional is the outside. So doors and windows, right? On the walls, essentially, and then any ceiling penetration that you have, whether it's speakers and all those things that I listed out earlier, those are really the biggest things to look for in terms of air leakage and envelope sealing. So no, I think we probably hit that.
All right. So then, as we sort of move through like this energy efficiency train that we're on here, um, let's talk through like a good order for homeowners. What should we do first? What things need to come before the panels land on my roof?
Yeah, so I would say any energy efficient upgrade that you can do, whether it's an attic tint, LED change outs, which most people are using LEDs now anyway, so that's not as big an issue. Your thermostat, that's a big piece. There's still a lot of people on mercury thermostats. And so
Really?
if you can get that upgraded to a smart thermostat that has a scheduling feature where maybe it's not running as often in the day if you're at work and so forth, that's a huge part of energy consumption. Um, Door and window sealing, making sure those are nice and tight. Air sealing, when even if you're not upgrading your insulation, if you go through and seal up the very big obvious holes in your attic, if you will, that's a huge, that needs to happen before panels, right? And then of course insulation before panels.
So any good insulator, right, is going to come in first, and they're going to offer you some sort of energy audit, I assume, right? Like where's this air going? How well is the home insulated? That should be step one, right? Let's figure out exactly what we're working with before we change.
Yeah, I mean that should be a part of every presentation. And now, realistically, one, not every homeowner wants that. They just want to add insulation, and two, not every contractor offers it because it really is an extra step and it costs several $1,000s to get certified and to understand what you're doing. And some people don't want that type of investment. But generally, I would agree with you, an energy efficiency audit to kind of see how much leakage you have, where it's coming from, and then a plan to address that, and then a test afterwards to see how much we were able to reduce that air movement, which you can typically apply to some additional savings that you wouldn't normally get by just adding insulation. So that definitely should be happening, at least in a conversation, if that's the direction the customer wants to go, because there may be a cost associated with an energy audit that you wouldn't normally pay to a regular insulator.
Right. And then after that, we just talked about this one, but air sealing, right? Sealing up all the troublesome spots in the house, things like that.
As many as you can get to and get done. On older homes, it gets very difficult to get every little hole, but whatever reduction you can do is money in your pocket.
Right. And then from there, that's when we start really talking about insulation. Your insulator is probably going to bring this up, but the kind of insulation that your home needs.
Yeah, so every region has a preference,
Right.
but you remember every type of insulation is going to give you the same R value. So there's no difference in R value that you get based on the type of insulation. Doesn't matter what you put up there. If you're installing it to the manufacturer's specs for whatever R value they spec out, it's not going to matter. Whether it's cellulose, which is newspaper that's been treated with a fire retardant and a wood rot preservative, or fiberglass, which is naturally fire resistant and not made of paper, or it's wool or hemp or blue jean or Milo, which is a grain that is puffed up like a popcorn that is being used in homes, or even wood.
Yeah.
There's wood products that are actually you can blow in or lay in like a bat for insulation. So it doesn't matter what it is, the R value is going to be the same.
And so the determining factor really is it cost?
Yeah, then it comes down to cost, right?
Yeah.
Cost and how quickly it goes in, how thorough it's covered, the areas that you're insulating. So blown in typically in the attic is your best bet because it's going to go in relatively even. It's going to fill all the nooks and crannies. You're not going to have a lot of missed spaces. Then you start looking at differentiating contractors by what are they going to do? Are they going to install ventilation baffles to keep the ventilation of the attic going? Are they going to install rulers? Are they going to give you a certificate that's easily visible when they're done, showing how many bags they installed to what R value? Which, by the way, all these things are code, but nobody enforces it because nobody's looking in your existing attic. On the new construction side, that's a different story, but an existing home, that's what it is. And then how comfortable you are with that contract.
Right. Cool.
The price is a huge factor.
Yeah. Well, and then once you've nailed down your insulation, then it's really time to move on to, um, you know, this is a kind of a different topic, but making sure your HVAC is tuned up, ready to go, and then we can start having that solar conversation.
Yeah, I mean, everything's so tied together. Even are your air conditioning ducts, are they hanging as straight as possible, or are they laying on the ground? Like all this stuff affects your efficiency. And a good insulator and evaluator, energy efficiency evaluator, is going to kind of walk you through all these things that can be done. Not everybody wants to do them. Not everybody wants to pay for them. But I did want to kind of talk about cost real quick, because I know that's going to be a question that comes up. Then I think we're going to roll into maybe some myth busters, right?
Cool.
So costs. Typically, spray foam insulation, let's just say 6 inches in the attic, which is typically what we see in the South, is going to run you anywhere from, I've seen a range anywhere from $1.50 to $2 a foot, right? 6 inches. 2 inches of closed cell foam, which is typically what we see in the South on metal buildings and or attics or walls, is going to run you anywhere from $250 to $315 a foot.
Oof.
This depends on where you are in the country. It's a pretty big range, but I would say, between 250 and 315, 315 being on the high end, 250 being on the low end. Blown in fiberglass at an R38. So if we're doing all 13 and a quarter inches, or it may even be a little bit more than that, depending on the manufacturer. I mean, you're looking anywhere from $1 to $1.25. A top off where we're getting you from whatever you have existing to that R38 should run you anywhere from depending on what you have, from 90 cents to $1.10, give or take. These are very general, and they're going to be dependent on your location and competition and material costs and all those different things. Blown in fiberglass, blown in cellulose is going to be about the same price. Not going to see much difference there. Fiberglass bats in the wall. Believe it or not, the bats are becoming extremely expensive.
Really?
And the cost for a fiberglass R13 bat in the wall is probably going to be in that dollar range. And spray foam open cell is going to probably be in that $1.25 to $1.35 range. So the cost differentiation on the walls is starting to narrow.
Yeah.
Starting to narrow. Generally, that's all very general pricing. And a good energy efficiency audit is going to run you $300. That's usually what they charge for that. But those are some general costs of spray foam and traditional insulation. And listen, if anybody's in the comments who sees this, you're going to get 10,000 opinions about pricing and how much it should cost and how much it should cost. And we can talk about pricing and margins in a whole nother call as it relates to any home service industry, including solar and insulation. We can do that another time.
But again, it definitely, like Darren says, it definitely matters where you are, what region of the country, and what your ultimate goal is, right? So cost, like Darren just said, we all know in residential construction, it's never just a cut and dry, easy answer for cost.
Right. And contractors are going to get a better price than homeowners because it's commercial versus residential. It's retail versus wholesale. There's a lot of factors in there.
Yeah. Cool. All right, brother. So let's knock some of these out real quick. Some of the things I've heard most over the years, right, is spray foam makes my house too tight.
So there is a real thing about making your home too tight, and there is building code around that. And so we talked about blower door testing, which is pressure testing. Most new construction homes require a test so that we know exactly how tight the home is, right? So if you're in a new construction home, depending on where you are in the country, your air changes per hour, which is that measurement, that blower door test of how much air is moving between the outside and the inside. It's called air changes per hour, ACH, has to be 5 or below. In some areas, it's 3 or below, depending on where you are and what code is being enforced. And what that does is it requires, if you're lower than those thresholds, it could possibly require you to bring in what's called mechanical fresh air, or bring in air into the home, make up air into the home so that the home is not too tight. So is that a real thing? Yes, it's a real thing. And it could be, you can get a home too tight even without spray foam, believe it or not.
Yeah.
Not typically, but you see it where a home meets the code without the spray foam. and then you see homes that meet code, obviously with the spray foam. And so, I'm going to say this, and there's going to be lots of dots behind it and opinions, but on a typical home that is 10 years old, you can spray foam your attic typically and not have to worry about the home being too tight or your air conditioning system short cycling where it's not dehumidifying the home properly.
Right.
Typically, you're going to be okay doing that. Every time you change a piece and component of the home, it changes the house as a system. I said that before. You have to treat the whole house as a system. Everything is integral to how everything else works, from the type of doors, type of windows, the size of your AC, all the amount of ventilation, poop fans you have, or kitchen fans you have. All that plays a factor into all of that calculation. So, generally speaking, most homes can have an attic that can be converted to spray foam without having to do anything major.
Yeah.
All right. There are situations where you do have to bring in dehumidification. There are situations where you may have to bring in combustion air for a gas appliance, or change out your gas appliance to a 90% efficient. There are situations that all that applies to in different areas of the country, in different ages of the homes, and different, I guess, ways people build their homes. So, but generally, spray foam doesn't make a home too tight in and of itself.
Good. All right. I think we have time for a couple more. Let's tackle fiberglass is just as good.
Yeah. So any traditional insulation is only as good as the person installing it, how much air movement is going through it, and how much moisture is affecting it. So I would say that spray foam, by the nature of foam, and everybody's used great stuff or seen foam board, doesn't allow much air movement, which means that there's not much moisture movement, because moisture moves through air.
Yep.
And that's the beauty of spray foam insulation versus a typical traditional insulation. So fiberglass is not just as good as spray foam, period, hands down. Fight me.
All right. Last but not least, how about insulation does not affect my humidity?
So I've already kind of gone through that. Spray foam for sure could affect your humidity, either positive or negative, depending on your house as a system. Typically a very positive thing. Traditional insulation doesn't necessarily affect your humidity, but the air sealing does affect your humidity in your home. So insulation can affect your humidity, and for sure, proper installation and air sealing of traditional insulation will affect your comfort and humidity. Absolutely.
Nice. All right. I mean, D, we blew through a bunch of stuff today. We stayed mostly on topic, right? Our big goal today was talking about reduce before you produce. So open cell, closed cell, we did spray foam, we did blown in insulation, all those sorts of things. So thanks a lot, brother. You even educated me a lot today.
Yeah, appreciate it. Yeah, it's always good to talk about what we know, and we do. You and I know a lot about home service, solar efficiency, and then we'll hopefully bring on guests that will be able to provide insight into things that we don't know, and maybe that's finance, maybe that's shingle rejuvenation. Thank you, Reviver Roof, by the way, for continuing to sponsor our show. If you don't know what Reviver Roof is, you can check out their website. Is the Roof Shingle Rejuvenator that comes with a 7-year warranty. So check them out if you get a chance. But there's a lot of topics that there's people out there who know way more than we do, and we want to try and bring some of those guys on and as guests. Just like Derek. Derek had a great insight into Virginia, but just generally solar and how it should look.
I agree. All right, D. Well, that's another episode of What's Up, Powering Stronger Businesses. You want to take us out of here? We'll see y'all next week.
Hey guys, thanks for joining us. Don't forget to like and share the podcast both on Facebook and in YouTube. The more subscribers we have, the more likes we have, the more people get to see our ugly mugs and get to comment on us. So we appreciate you guys for joining us. Thanks so much for the support so far. Make sure you like and share, and we will see you next time. Bye.
Bye.